Hey everybody, let's start Unit 2. We're talking about something completely different. We're talking about arithmetic and geometric sequences. So hopefully you've heard this term before, but if you haven't, let's talk about what a sequence is. A sequence is an ordered list of numbers. So literally, it cannot be every value. It is very specific values. And this list could be finite, where there's a set number of values, or they could go on forever for all the end of time. So each listed number is a specific term, okay? So for example, in this set, we know that this is infinite because of this dot, dot, dot. This dot, dot, dot tells me that it's infinite, therefore it's going to go on forever. So this number 1 is, we call it the first term, okay? So if it's the first term, we'll call this A, which means term in math, sub 1. So we'll say this first term, but we see the symbol A sub 1 is first term. Okay, this is our second term. This is our third term. This is our fourth term, and so on. We know it goes so on because it's got that dot, 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 which means it's going to be infinite. We can see this graphed over here. The graph of the sequence just contains discrete points. This is a very specific math term, which means that these are values that are not connected. So we are not going to draw a curve through these. We're not going to draw a line through these. These are specific values. So for example, if this is the term, so this is the first, second, third, fourth term, and these are the values, 1, 2, 4, and 8. This list would be, the terms would be 1, 2, 4, and 8, where this is the first term, second term, third term, and fourth term, okay? So let's talk about the pattern of an arithmetic sequence. This pattern means that it's basically adding the same value every term. So each successive term has a sequence that's called a common difference, which means every number has the same difference from the number before, okay? So we say, hey, this is the nth term, where we start with a naught. Go ahead and say that with me, a naught. And it's just a mathematical way that we say a sub 0 is a naught, meaning the initial value, plus d, where d is the common difference, and n is the number term that we're looking for. So again, a naught is the initial value, or the 0th term, and d is the common difference. So let's talk about what that would actually look like. So this says, find an equation or a rule that represents the sequence 2, 5, 8, 11, and so on. This is infinite. Using your equation, find the 100th term of the sequence. So we're going to use what we learned here, that we can find any nth term to find this, okay? So let's go ahead and first look at what is the common difference. Here's how we can discover it. If I go from 2 to 5, I know I had to add 3. From 5 to 8, I had to add 3. From 8 to 11, I had to add 3. And because I'm adding 3 every time, this is my common difference, that it's a positive 3. So in order to find the nth term, remember we're going to take our a naught plus common difference times the nth value. Well, here's the thing. This here is our first term, second term, third term, fourth term. We need to find the a sub 0 or a naught term. So here's how you're going to do that. If this is a 4, 3, 2, 1, here would be 0. So what would the number be here? Well, I know if I'm adding 3 to the right, I'm going to subtract 3 to the left. So as we're going through this, here's 11 minus 3 is 8. 8 minus 3 is 5. 5 minus 3 is 2. 2 minus 3 would give us negative 1. So we know that that's our a naught term. So we're going to say negative 1 plus d, we already said was 3, times n could be any term. So we know any nth term is going to be a naught, which is negative 1 plus 3, common difference, times n. So we can also write this for any term, not just using the initial term, aka a naught. And we can write it like this, that the nth term, which is any term, can be a sub k, or the kth term, plus the common difference times n minus whatever k is. So here's what this means. Where a sub k, or the kth term, is any term of the sequence. So this is what it looks like. So if this is the where k equals 1, that's like saying the first term. Okay, so here's what that looks like. So when we look at this, if I know that it's going to be k is 1, we're going to look at a1 plus d times n minus 1 because k is 1. So let's figure that out. So in this equation here, this sequence, this is 1. So we know a sub 1, or the first term, is 2 plus the common difference. Well, what was it? We know this plus this is, we're going to add 3, we're going to add 3, we're going to add 3. So here, the d equals 3. So we're going to put that here. And then n minus 1 because the number k is 1. Let's do the next one. I know using this rule again, where k is 2, we're going to use a sub k, which is 2, plus d times n minus, in this case, k is 2. So what's the second term? Well, we know this here is the second term. That's 5. Plus d, we already said was 3, times n minus 2. Okay, push pause, and let's see if we can do the next one. All right, hopefully you paused there. For this one, we know if we're looking at k is the third term, k is 3, so we're going to find the third term plus d times n minus 3. Well, that's the third term is 8 plus 3 times n minus 3. And then the fourth term, or k is 4, we say the fourth term plus d times n minus 4. So we say the fourth term is, we know it's 11 plus 3, which would you know, d minus n minus 4. And if I were to simplify all of these, multiplied and distribute out that number into the parentheses with the n, these would all be the same rule when simplified. So when you're simplified, it's all going to be the same rule. This is helpful when you only have a specific value and not every value, okay? So let's talk about the next one. Subtraction is still arithmetic. The only difference is it's just adding a negative number. So let's look at this here. This is our first term. Here's our second term. Here's our third term. Here's our fourth term. So here I know from 7 to 2, I know I'm subtracting 5. So then in this case, this common difference is negative 5. So since I know it's a common difference of negative 5, we're going to use the first term where k equals 1 to make the rule. Well, the rule is going to be, okay, any nth term equals the first term plus d times n minus, well, 1, because that's your k. Well, d, we discovered, was negative 5. And then the first term, we already know, is 7. So we say 7 plus negative 5 times n minus 1 is your nth term. All right, let's talk about a geometric sequence. So if arithmetic is adding, geometric is multiplication. So if each successive term in sequence has a common, not difference, but ratio, or a constant proportional change, the sequence is geometric. The nth term of geometric sequence is given by the initial value of the geometric sequence, or g naught, times the common ratio to the nth power, where n is the number of term that you want, where g naught is the initial value and r is the common ratio. So let's go ahead and use this. So here I know this is my first term, here's my second term, here's my third term, here's my fourth, and I know this is going infinite. Now I need to see, is this geometric or arithmetic? Well, I know from 2 to 6, if it was arithmetic, I'd add 4. But from 6 plus 4 isn't 18, that would be 10. So I know for sure it's not arithmetic. Let's see if it's geometric. Now this is how you can tell if it's geometric. So r is any term divided by the one before it. So you would say any term divided by the one before it. So let's say, for example, 6 is my second term. Well, 2 minus 1 would be the first term. So what's a2? It's 6 divided by a sub 1, which is 2. 6 divided by 2 is 3. Let's double check to make sure that this also works. 18 divided by 6 is also 3. And if I multiply 18 times 3, we get 54. So I know that the common ratio is positive 3 in this case. Okay, so now that we know that the common ratio is positive 3, let's go ahead and write the equation for any term, not just the initial term. So before we do that, let's use this one here. So we know g sub n, or the nth term, equals the initial term. Remember, how do we find g naught? Well, I'm going to take the first term and divide it by that common ratio. Actually, I should probably write this down. To find g naught, we're going to take the first term and divide it by r. So in this case, it's 2 divided by 3, because that would be the pattern to work backwards. So our g naught is 2/3 times r, which we know is 3 to the nth power. Okay. We can also use this, we can write this using any term. So we can say, if any term is k, we can say, okay, the kth term of the geometric sequence times the common ratio to the n minus k power, where g sub k is the kth term of the sequence. All right, let's answer this next one. What are other ways that a rule can be written for this specific sequence? 2, 6, 18, 54. This is our first term, second term, third term, and fourth term. We know it goes on forever, and we're multiplying by 3 every time here. If I want to double check that, I know 6 divided by 2 is 3, and so on. So r, the common ratio, is 3. So what are some other ways? Well, if let's say I wanted to start with the first, where k equals 1. This tells me that I can take the geometric sequence of any number, and we're going to go the first term, which in this case is 2. So g of 1 times r to the n minus k power. So g1 is 2 times the common ratio is 3 to the n minus k is 1 power. So this would give me the rule for any term if I have that first term. But what if k was a different number? What if it was 4? So in this case, we would use, okay, any nth term of the geometric sequence would be g of 4 times r to the n minus 4 degrees. So the fourth term is here. Here's 1, 2, 3, 4. It's 54. The common ratio is still 3 to the n minus 4 power. And again, this is going to give you the same rule as the other one if it was simplified. Last one, number 6. Division is still geometric. The difference is we're just multiplying by a fraction, somewhere between 0 and 1. So what's a rule for this sequence here? So let's zoom in here. If I take this 16 and I divide it by, so if I take r2 divided by r1, that would give me, or I should say this is an a. a2 divided by a1, that's your r. So what's 16 divided by 64? I can simplify this to 1/4. I can also take this one, or that fourth term, any term, divided by the one before it, which would be also 1/4. So we know the common ratio is 1/4. So when k is 1, that means, hey, the nth term equals the 1 sub k times r to the n minus k. Well, in this case, the first term is 64 times r to the n minus k is 1. And that's our rule. All right, I'll see you at the next class.